Hey everybody, this is Alex Merced, and welcome to another episode of Catalogs, Manifests, and Metadata. Oh my. And in this episode, again, this first sort of batch of episodes are going to be really about sort of just understanding, particularly the Apache Iceberg project. I will get into other open source projects down the road, but I want to just build sort of a core sort of knowledge. And basically, to understand what Apache Iceberg is, we need to understand what a table format is. And to understand what a table format is, we need to understand the paradigm of a data lakehouse. So this episode is going to be focusing on sort of what is the data lakehouse. And essentially what the data lakehouse is, it's a evolution of data architecture. So the bottom line is, we just want to run analytics to get insights. We want data to either be what fuels our business intelligence dashboards or BI dashboards, essentially graphs and pie charts and visualizations of our data that help us understand the data better. We want our data to be able to fuel reporting for regulatory purposes and also just internal reporting. We want our data to be able to fuel sort of AI and ML systems, which could be fueling sort of like large language models, kind of like think of like a ChatGPT, or fueling like recommendation engines, whatnot. Our data can do lots of things for us, but there has to be systems of delivery. Okay. Now, oftentimes when it comes to operating our application or operating a business, you're doing what's called transactional work, and you store your data in database systems. And then later on, when you want to run analytics, you store them in data warehouse systems. And these systems, they abstract a bunch of stuff for you. Okay, they do a bunch of things that we just don't have to think about. When you put data in a database like Postgres, it just kind of works. You're not really thinking, how does Postgres store the data? How does it distinguish one table from another? How does it know which tables exist? And how does it process a query? And same goes for data warehouse platforms. Okay, they just kind of work because the software abstracts all these implementation details. And that works great, and that has worked great for a really long time, to have the software that just kind of takes care of all these details for you. The problem is, running these database systems can oftentimes take work to manage. Nowadays you have cloud services that take a lot of the work of management out, but you still each system tends to store the data in a way particular to that system. All those pieces that are abstracted are particular to that system. So in that case, if I want to use multiple systems, because there's multiple use cases that different systems are ideal for, I have to kind of make multiple copies of my data into each system. Which means data engineers who are in charge of moving the data between these systems have to do more work. They have to write more code about moving, the same data from point A to point B, and making sure that it's tested, deployed, and then there's the cost of running that code, the cost of storing that data. So that work takes time, so you're increasing the time it takes to deliver the data, and you're increasing the cost, which again was fine for a really long time, because the speed at which you needed the data, the scale of the data, the costs weren't too bad, and you were delivering the data generally on in times that were acceptable. Okay, but now you need data faster and faster. Okay, you start hearing that conversation of real-time data more and more. Now, the data is becoming so huge, and the number of these processing jobs are so large that these cloud bills, or these basically the costs, is just getting pretty gigantic. So the idea would be, I could reduce the cost if I didn't move the data as much. And typically in these patterns, there's an intermediate system called a data lake. Essentially, the data lake is just a storage layer. Okay, it could be a Hadoop cluster, could be a object storage, but it's just somewhere to store data. And the idea is that the data lake allows you to since you're just really storing files, you could store data that's structured. So structured like databases and data warehouses, where generally the data is structured as columns and rows, tables. And unstructured data, which could just be, like text data like emails, sensor data from IoT devices, sort of data that you can't really necessarily, it isn't in its raw form ready to be stuck in a database or a data warehouse. So you could just put all that data there and then use it as you need it. And you can do it at a very low price point. So a data lake was really good for sort of providing this dumping ground of data. And there were tools that could help you query that data. So like a really popular tool for querying data lakes is a tool called Dremio that allows you to, run queries, SQL queries, and to run analytics on that data. And it works really well. But oftentimes you're just running analytics. You're not transforming that data. So bottom line, there's a lot you can't do with the data in this paradigm. And so you still need to move the data into a data warehouse. So what if I could skip that step? What if I could make that data lake operate more like a data warehouse? Well, that's where you get the paradigm of a data lake house. So when we think about it, we have two of the pieces that make a database or a data warehouse. We have a storage layer, so your data lake is your storage layer, and we have a processing engine, a tool to run queries, and an example of that is Dremio. But what's missing is a way to track individual tables and to be able to understand the collection of tables, okay, a catalog. And I mean, technically a tool like Dremio could implement its own proper way of doing these things. The problem is then you end up back in the same place where you are in a walled garden where only that tool can understand your data lake. So this is where the world of sort of open formats for these intermediary steps kind of comes into play. So you end up with a table format that allows you to say, hey, these 1,000 Parquet files or these 1,000 files on my storage are a table. Okay, so basically when a tool like Dremio looks at your data lake, they don't see 1,000 files as 1,000 files. They see it as a single table and can understand the dynamics and be able to understand that table intelligently to plan on how to scan that table effectively. And that's what table formats like Apache Iceberg, Delta Lake, and Apache Hoodie do. They provide a metadata layer to understand what is a table and intelligently scan it. And then two, you need a way to kind of collect all those tables and be able to understand them. So that way, not only a tool like Dremio can understand that these tables exist, but you can take that same catalog to other tools like Apache Spark, Apache Flink, and other popular data tools, and they'd be able to understand what tables on your data lake in the same exact way. And a good open source project for this is Project Nessie, which will be something I'll talk about also within the scope of this podcast, as it's an open source project. So you have Nessie and you have Apache Iceberg. So Apache Iceberg acts as the table format, Nessie acts as an open source catalog, and both of them are open. So meaning any tool can sort of adopt them. Any tool can choose to understand Nessie catalogs. Any tool can choose to understand Apache Iceberg tables. But the thing is that these two things provide sort of the level of abstraction needed not only to operate like a database. You can now understand, hey, these are the tables that exist, have metadata that allows you to operate those tables and do ACID transactions and all sorts of other types of transactions that weren't possible before in the data lake, creating what's called a data lakehouse. So now you don't have to move your data to the data warehouse. So you save the cost of having to create that copy of your data. You also save yourself the time of doing all the work that would take to do that. So you're delivering the data faster at a lower cost. And the cool thing is you can now move that data between different tools because different tools can understand these open components. Different tools can connect to Nessie and Apache Iceberg. And so in that case, you might use Dremio to do a lot of your analytics, but maybe you're doing some AI/ML, so you might use like Apache Spark's AI/ML integrations. There's different ways you can kind of do this, and they can all connect to the same data without you having to constantly replicate the data. So that is the gist of what is a data lakehouse. Hopefully you guys enjoyed this episode. Make sure to subscribe to the podcast and tell your friends about the podcast. Make sure to follow me on LinkedIn. All the links are in the episode description. Have a great day and enjoy.